Hello, everyone, and welcome back to listening to the videos about our first unit, which will be the introduction to advanced level design. Um, and so basically, uh, this video will cover the contents of the first chapter of your advanced level design book, the first volume of the Mastering Unreal Technology that you have. Um, so if you've gone over the syllabus of the class, you'd know about the basics, how to reach me through my email address. There's the uh, voting process online that you could go on and choose 3 times 1 hour time frames every week that we will uh, see how it works to be the most convenient for everybody, and then I'll post the meeting times online, or you can set up an appointment if you need to talk to me. So for this week, to cover the materials from the class, uh, um, I would like to tell you about what the context of the class are, the textbooks that we will be covering, as I said, and you've read from the syllabus as Mastering Unreal Technology Volume 1 and Volume 2, and there's a recommended textbook, it's not required, about art of level design, and if you're interested you can also study that. What we will essentially talk about is to see how you can use Unreal Development Kit that I showed you how to download. There's a video on this topic about downloading your copy of Unreal Development Kit, and then you can go on YouTube and subscribe to UHV Gaming on YouTube, where these videos will be posted, so you could have access on them after the class when the Blackboard will not be available. So if you want to think about what happened in terms of designing games and game engines from the beginning of the history of the game engines, you will notice that the game development process has gone through a serious series of changes, and the changes essentially started from the first moment when the industry or the gaming technologies became available for the public, to make it more efficient, to design games, make it more profitable for the development studios that create games, and so forth. Now, one of the probably most advanced um, on gaming engines and gaming technologies that incorporated a lot of different tools and technologies into one single source, so people could create contents useful for games, is essentially the Unreal Development Engine. And it was introduced to the gaming community back in 1998 with the introduction of the game Unreal. And with that Unreal game, with its introduction, there were a couple of topics that were added and were essentially added not just as game contents for the users to play with, but also as development contents for the users to be able to tweak them and work with them. Pretty interesting environments, realistic looking materials, the introduction of bots or artificial intelligent agents within the game that control non-player characters or NPCs, and the concept of a well-developed game engine that users could use to modify the games and create their own modifications and their own even games, and a nice little language called Unreal Script that enabled the users to extensively mod the games and change the contents of the games. It was basically that year that changed the way people actually create games, essentially. And the single player engine for Unreal was nice enough. In 1999, a year later, Unreal Tournament was released by Epic Games, which was the creator of the Unreal game. It was a multiplayer engine, and it has very good online gameplay mechanisms and a real nice advanced artificial intelligence, at least by the standards of the time, incorporated within the game. A few years later, in 2001, the online community uh, became so pervasive and so much involved with developing and modifying contents for Unreal and using the Unreal Engine that Epic Game designed the Unreal Development Network and released the UDN, which is essentially the place that contributors would contribute code, contribute materials to, and so it gives you up-to-date documentation and information about the engine. A couple of years later, there was an Unreal Championship, Unreal Tournament 2003, and based on all those changes that happened within the Unreal Engine, the newer engine Unreal 2 was released, which had even better multiplayer capabilities. In the year 2004 and 6, Unreal went through more development. Unreal Tournament 2004, based on the Unreal 2 engine, became available and was released, and that was a big hit. And essentially, based on Unreal Engine, the newest contribution to the field of gaming, essentially through the game of Gears of War, was developed, which is a third-person shooter that uses the Unreal technology for its content creation and also its engine. And all the way to the release of Unreal Tournament in 2003, late 2007, which was probably the latest contribution, essentially at that point, that solidified the Unreal technology as one of the most advanced game development engines. And if you're taking the game engine with me, we'll discuss the way that Unreal is set up and what makes it a different um, uh, game engine compared to others in the industry, and what made it really great for the kind of things that people can use Unreal for and contribute contents to. So this is a history about Unreal. So what you look at when you're looking at Unreal is essentially a game engine. So it's not a game per se, or at least the Unreal development engine is not just a game itself. It's the way that different content creation tools and different aspects of the game are placed and formatted and categorized with each other and with respect to each other, that creates a highly modifiable set of tools for creating almost any kind of game within the engine. So essentially, it's organized into different kinds of assets. So you may have different kinds of tools, objects, materials, audiovisual materials, music, textures, maps, three-dimensional content, and all that kind of things. And all of these are categorized. Even advanced topics such as lighting conditions, light maps, animations, animation trees, and so forth. And all of them are categorized within different kinds of assets, and there's an asset management mechanism within the Unreal game that could incorporate all these into the game engine. And the Unreal engine uses that data essentially and passes this data back and forth between its completely independence of components, such as graphics components, sound components, physics components, and so forth, efficiently to create the content and material for the games. So the Unreal Engine is made up of the subcomponents, and each of those subcomponents essentially run on their respective hardware and software mechanisms. So what essentially these subcomponents do, they act as translators. So when you're looking at an asset within the game, it's just a bunch of zeros and ones, and those zeros and ones from a raw data would go through the subcomponents, and then they would be translated into the environments that you will see. An Unreal Engine with its own subcomponents is the process that takes care of this translation and the creation of the contents that you will see. What type of things are involved with the content translation from a binary data format for an asset to or a game asset to a character, for example, on the screen, would be things, for example, light modeling, how the light would interact with the materials, how the shaders would basically render materials on the surfaces that you have, hidden surface removal, which is a very big component of any kind of game engine that or a rendering engine that would ensure efficient rendering of your materials on the screen. But when I was talking about this. I used the word rendering a bunch of times, and if you had taken other classes, you'd probably have an idea what rendering means. Essentially, rendering is drawing, and what that means is that you have a bunch of data, but eventually, what your players, what the people who are interacting with the game will see are bunch of pixels, zeros and or essentially color pixels on a two-dimensional screen. So rendering is taking care of all the three-dimensional uh, geometrical relationship between objects, the contents of the objects, their materials, the surfaces, how the light would interact with them, and translating all that complex information into just the colors on a two-dimensional screen so that you will see. So think about this picture that you see here. Uh, the person that you see with all the complex uh, shading reflections that you see on the screen is just a two-dimensional screen, but it conveys to you a three-dimensional sense of the object and the way that the light interacts with the object. So that is essentially what the rendering takes care of. The Unreal Sound Engine takes care of creating sound effects. So to do that, your engine would interact with the sound hardware on your computer or on your gaming console to create the sounds that you will hear. The sounds input could be recorded audios or clips that people could create with different kinds of sound mechanisms and software packages, and then you can input them and use them within the Unreal Engine with the sound engine and the sound editor mechanisms that Unreal has, and create simple little sound cubes that then you can put them together, and you can even have scripting materials on top of them and create the sounds that you want. Certain events will trigger these sounds. For example, when a person shoots at an object or an opponent, you will see the visual aspects of shooting the guns, but at the same time, that can be used as a trigger of playing the sound of the gunshot. And the sound of the gunshot would be a sound cube that you would essentially use Unreal to play and uh, kind of uh, give that idea of audio effects that you want your game players to feel and hear. And then you can also use the sound engine to recreate sounds by combining them together. As I said, there's a very good sound editor mechanism in the Unreal, or you can use any other kind of sound editor of your choice, and you can make sounds loop or fade in, fade out, and any kind of sound effects that you wanted to put on the sound materials. But then think about it. With the sound and the rendering mechanism, you will have a tool that enables you to show things to your players and also let them hear interactions between objects from the scene. But for the players to feel really at home, feel connected to the game that they are playing, you would have to have some sort of physical properties for your objects. And to create these physical properties, you would have to have an engine that solely takes care of those physics relationships and simulates the physics of the dynamics of your game materials. If an object hits the wall, the way that the object would bounce back off the wall depends on the content of the object, what the object is made of, and the laws of physics that govern the area where those objects are in. And to do this rendering or realistic rendering of this physics and dynamics, you would have to have an engine that independently works on those materials and those stuff, takes care of collisions when two objects collide with each other, and what happens after the collision happens. And this is carried out in the Unreal Engine through NVIDIA's physics engine, which supports many kinds of physical simulations, and it's done through rigid bodies, constrained bodies, and dynamic skeletal meshes. An example of a dynamic skeletal mesh and rigid body are this player here, the character here, and the cylinder. So the cylinder is a rigid body, and the player is a dynamic skeletal mesh. And when the two hit, the physics engine kicks in and takes care of all the things that happen to the body of the player and the cylinder object itself. And recreates that physical simulation and creates the animation, send that animation to the rendering module, and the rendering module would render frame by frame of those animations, and you will see how this is done. If you don't have a dynamic skeletal mesh and the physics, rigid body is physics governing this sample, if the person is just standing and the physics body hits it, nothing would happen. The physics body or the rigid body of the cylinder would just go past through the object, which is not realistic. And you can also hook up the sound engine and the physics engine together so that you could play a little collision sound here within the engine that would also realistically render the physical sounds that you would hear otherwise in real environments. But to make all these things work, you would have to have a kind of front-end mechanism to manage all the bits of assets that are coming in as zeros and ones into your engine, and separating all different kinds of objects that you have, from a rigid body object for a physics engine to a sound cue that goes to the sound engine, or to graphical representation of your game. You would have to have some sort of input, and then also on top of that general purpose input that you would present to your game, that would create just cinematic events like little movies and little clips, for the players to be able to tell the game what they want it to do for them, such as moving a character forward. You would have to give some sort of inputs that would interact with the human, and then let the human interact with the game itself. And so the input manager in the Unreal Engine takes care of mouse button presses, keyboard button presses, any kind of analog controller or vocal commands that you have. And so those kinds of inputs are dealt with through the input manager of your game. And this works with the core engine, the physics engine, the sound engine, to simulate responses to the inputs that are coming from the player. And this takes care of, for example, when a person presses the fire button, that button would trigger the effects of shooting a gun, for example, firing a gun, and then triggering the sounds of a gunshots being fired, and so on and so forth. So these engines work closely with each other to create those mechanisms for your game. If you want to incorporate more than one player, one human player in your game, you would have to deal with multiplayer engines or multiplayer settings for your game engine. Unreal supports that through a client-server architecture, and you can set up dedicated servers that only run the engine on one machine or several machines as servers, and you won't play games on them, but they take care of the network management and the client-server communications between your client machines of different people with different settings of hardware and software architecture to play the same game. And to manage a efficient network for this purpose, you would have to essentially make an efficient network architecture that would take care of all the interactions that are happening within the environment and the interrelationship between players and the environments. So the network infrastructure in the Unreal allows you to basically do that. Now, in terms of network mechanism and using network capabilities for Unreal, there was the third edition of the book, the third volume of the book that was coming out, but it was not released. It was supposed to be released earlier last year in 2011. It was not released because the majority of the content of the book is already on Unreal Development Network that I talked about earlier. And so if you're interested in network programming using Unreal, Unreal Development Network through Unreal Script has a vast amount of information on network architecture and network programming for multiplayer games using the Unreal Engine. And unfortunately, as I said, the book is not coming out. The book would have been a great uniform source for you guys to read about, and that was in fact one of the things that I had in mind to use as a textbook for the game network architecture, but unfortunately we will not have that book released. And but again, as I said, the information from that book is already on the majority of it is pretty much on the Unreal Development Network. And as the Unreal development kit is essentially evolving really rapidly, almost every month there is a new release of the game and new aspects of the game engine. You will see that some of those contents of the book, by the time it comes out, become either obsolete or rather basic. And so, using the Unreal Development Network probably is one of the best sources to uh, go to for such advanced materials like network architecture within the game engine. Now I talked about the Unreal script a little bit, and that it is highly versatile for use in networking. It's basically a simple scripting language. It's very similar to C++, and you do not need to touch the source code to create this visual effects that, or even the networking architecture, as I said. You can use this Unreal script, and this is really good because first of all, the, in order to really write for the source code and really write the source essentially in C++, it would require lots of experience, especially in high performance programming, such as heavily object oriented for C++ programming. However, for doing things with the game engine rather than within the game engine, you could use Unreal Script. So you basically simply write your script, like how you want your players to react. If you want different kinds of shadings on materials, you could write scripts for that and then send them to the Unreal Script interpreter. And the interpreter, or Unreal Script interpreter, acts as a middleware here between Unreal Engine, which is the actual C++ code, and your Unreal script that you wrote, and translates this into the language that Unreal can speak. And you can and essentially it does whatever you want it to do through the scripting language. And if you've worked with Unity, you already have some scripting experience. That pretty much translates again into Unreal. It's really simple to do. It's not really difficult. If you look at this piece of code that you have here, so essentially you create a player, and then you have some sort of text on it, and then you have a conditional statement, and you compare a bunch of stuff, and if that condition is true, then you create specific loop that or actions and interactions that you wanted to happen, and Unreal Script Translator would translate that to the engine, and that sequence of logic that you implemented through the script will occur within your game. Now, I want to talk a little bit about how a basic game loop before the intervention and the introduction of Unreal had set up, and what is the differences between what a general game loop looks like and the basic event system within the Unreal technology. If you look at the general game loop, you have different kinds of engines that would have to run, generally speaking, concurrently, but then there would be a number of CPUs. In the older systems, there would be only one CPU that would take care of all these processes, or if you have multiple CPUs, your process is still some sort of a temporal process. So things happen in a temporal format, and so there's a scheme or a mechanism of time sharing between different components of your game. So a general basic game loop would start with initializing your game. So if you, for example, click on the executable file of a game, and then you see the first screen comes up, and then you'd see that the game starts loading, and a little progress bar would just go on, and that is essentially the initialization stage of your game. All the memory requirements, memory modules that need to be set up within the game will be set up. All the initializations that would have to happen on your graphics engine and your sound engine and your or rather hardware would start, and then the game loop will start. And when the game loop starts, a series of actions would take place. The screen will be refreshed, the CPU will be given access to the data from the RAM that is loaded up through the initialization process, or if more material and information needs to be loaded up into the RAM, that will happen. Then a polling system or a polling mechanism would check all the input materials that are coming from different input sources, such as a joystick or a keyboard or mouse, or other kinds of input mechanisms like a steering wheel, will be gathered, they will be passed through different engines, all the things that need to be updated will be updated, and then this loop will start again. And usually this loop would happen so fast that the players won't be aware of these happening. So you won't see that. Hopefully, if the loop works efficiently, when you press the button, you immediately see the reaction. Although the reaction would have happened at the end of the loop, things would have updated later on, and then when the loop starts again, you would see your reactions taking place on the screen. That would happen so fast and so efficiently that you would basically see things almost instantaneously. In Unreal, there's a new introduction or a new paradigm introduced into the game loop, and that is the concept of events. And this is essentially the game engine that Unreal is based on is an event-based system. The difference is that there are some engines and some components in your game that they don't have to be refreshed or be taken care of every single time in the game loop. Some of the things would have to happen at a particular time when they are triggered, which is essentially through a mechanism called an event control. And you can see that on the fourth square on the second image here to the right. So your game loop still needs the initialization. So you would initialize your game. The process is pretty much the same. It takes care of initializing all your hardware subcomponents of the engine, loading up the materials and the data files and the assets into your game, and the loop starts. Then the inputs are checked, and then if any event, such as for example if a gunshot is fired, that would trigger a visual event of showing the animation for the gunshot, a sound event that plays the sound of the gunshot, and the physics event of taking care of the projectile that was shot from the gun. And all these things initiate their own event controls, and the event controls would just go through the process of or go through the mechanism of being processed, and each of those events would be taken care of by their own subcomponents and sub-engines. And at the end of that process, all of the things that need to be updated, for example, the screen, the speaker input from your game engine, and so forth, all of those things will be created for the update stage. The update process will happen, and then the loop restarts back again, and same process goes through. But if some particular sound engine doesn't need to be triggered, the event control will not happen, so that would not be taken care of essentially, because nothing needs to be taken care of, and so your game loop runs more efficiently. And this event-based system, essentially after that the introduction within this the Unreal Engine, is now pretty much taking place in almost all the other engines that are out there. So with that mechanism and architecture for your game loop using Unreal Engine, your game engine essentially goes through these processes. So you have the game core or the engine core that deals with and communicates directly and independently with the graphics engine, the sound engine, your physics engine, and your Unreal script interpreter. So first your game initializes, so your core engine starts initializing, and then it initializes in turn the other components within the engine, and it receives data for synchronization. So it synchronizes all of your other components, such as the sound engine with the physics engine and sound engine with the graphics engine, and so forth. And then the game launches, and after the launching of the game, where you see the maps being loaded into the memory, the textures will be applied on the surfaces, the meshes will be loaded into the engine, and if any of those meshes, such as skeletal meshes, require any kind of animation, those will be applied on them, and the assets will go to their respective engine. So if you have a rigid body, all of the contents and the interactions that will happen upon that object will be taken care of in the physics engine, and the materials will go through a process of being applied on your engine, and then the graphics engine would take care of interaction of lights and the materials and rendering of your screens. And within the game event, the gameplay, when you're playing the game, your events will be prioritized. So one of the highest priorities are to take care of the physics materials, and the other priority is to take care of refreshing of your screen so that you wouldn't see flickers on the screen, and so on and so forth. And all of those priorities of the events will essentially set them up within the game loop. So if you have the gunfire sound and a high-speed projectile movement on the screen, they will occur upon their own priorities. So higher priority events will be taken care of more frequently and faster, and they're preferred and essentially given preference by the game engine over the lower priority events. So this is the same mechanism for games and any other visualization projects. So as you saw here so far, all of the things that you play with in your game, they are different kinds of objects, and there are different kinds of assets that are created with different kinds of software packages. And so you would have the maps, which are the levels that you play your game in. You'll have textures and materials applied on different kinds of objects. Your objects, of course, may be static meshes, or they may be animated objects and skeletal meshes for characters with limbs. And on top of that, you will have your sound objects and sound cues that will be played by the sound engine in your game. So all of these things require creation. And the most efficient way to do this is to use their own software packages that are optimized for creating that kind of content. For example, to create a three-dimensional object, you would be better off to use a 3D content creation tool such as 3ds Max or Maya to create your objects. To create textures, it would be best to use a two-dimensional graphics manipulation tool like Photoshop or its free counterpart GIMP. And when you have your contents created, then you can export them and then import them within your game engine and then put them together and create the contents for your game. And what we will be dealing with essentially is to create your game maps, or also called levels or scenes. And you store these scenes as the assets for your game. And these scenes or levels contain the geometry of your game, which you will basically use them as the decorations within your game. And when you create those, you can export all the materials that are created and used within that level to a level package, and this level package stores the assets that you will be using in the game. And if you have any kind of assets that you won't use, you can call them, and Unreal automatically does that. Let's say that you have in your game, you have a bunch of materials as assets that you have been working with, but if you have those materials, you never use them in that level. So when you load that game the next time, or that level the next time, Unreal automatically calls those assets, and you wouldn't pull them off from the package into the memory. So that would be a bit more efficient in terms of managing and maintaining your levels. What are textures and materials? Of course, textures are two-dimensional images. They require texture coordinates, such as UV coordinates. We talk about them intensively a bit later in this semester, and you can use any kind of two-dimensional graphics software package to create those images. They could even be as simple as a two-dimensional picture that you took by your digital camera from a brick and then loaded it up into your three-dimensional modeling software to apply it on the surface of an object that you created to give it the look of bricks. On top of it, you would have materials, which is a bit different than textures, and that is textures would have the two-dimensional visual information about the object's looks, but materials will contain various properties of your objects. And what they do is that they enforce the interaction between the object and the light that has been set up or will be set up later on your game level. And so it would give the specularity visual component, the shininess on your objects, the diffuse properties of your object. If you have bumpiness on your object, that would be also taken care of within the material property. And the normal maps are the physical deformities, such as bumpiness on your object, that are also incorporated within as a component of your object materials. And we'll deal with those kinds of tools with the Unreal Engine. And here I have a question. I'll give you a few seconds to think about which engine is responsible for rendering the materials. while I again emphasize that your materials are basically the properties of your objects and how they interact with light. If you think of the object having a particular kind of color, you will not be able to see that color if there's no light in a complete dark room. The moment you put a light in the room, you'll be able to see the color, but you just won't see just the color. If it's, say for example, red, you just won't see the redness of that object, but rather you would see and feel what material that object is made of by seeing how it looks. And that how it lookness of that color or that material, or that object, is what is incorporated within the components of its material. So if it's metal, it will have a different look. Like for example, a red metal would have a different look under the same light than a plastic red object. So those kinds of differences are applied in the material. So to answer that question, your graphics engine is the part that is responsible for manipulating and rendering your materials on the objects. Of course, objects in your three-dimensional games that you will create within the Unreal Engine are three-dimensional objects. Usually three-dimensional objects are made up of polygonal meshes, and to render them really efficiently, the graphics cards nowadays require your materials or your objects to be made completely of triangles, and we call them triangular meshes or faces. And these are in turn made up of vertices and edges, because each triangle is made of three vertices or 3 points and three edges connecting each two pair of those 3 points together. And so each object made up of a whole bunch of triangles is essentially made up of vertices and edges. And these objects, or three-dimensional objects in your Unreal Engine, we call them static meshes if they're not animated or their subparts do not move with respect to each other. These three-dimensional meshes render really efficiently because, as I said, they're optimized for being run on graphic cards, and so they render really fast. You cannot animate their vertices, as opposed to a rigged body or an animated object or a skeletal mesh. So their vertices are fixed, and they are optimized and extremely efficient to be instanced. What that means is that when you create an object, let's say you create a cube, and you have a scene that is made up of 1,000,000 cubes, you can instance that cube 1,000,000 times. But when your graphics engine is rendering the cube, it doesn't require to create 1,000,000 cubes. It just creates the first cube and then uses their scale and the rotational and transformational information from all the other cubes to render them without having to recreate those cubes. So what this means is that it creates one cube, and then for all the other cubes it just changes their size and moves them around. So essentially it is an extremely efficient and fast way of creating a bunch of geometry by just creating a few or very little geometry using your graphics card. And so the only information that needs to be stored in your memory, and your graphics card processes them, is the first instance of your cube, and all the other information is basically your geometric transformations of the cubes with respect to the original cube that you created. That's the process of instancing. We'll talk about that a bit later this semester. There's other kinds of materials and objects. The counterpart of your static meshes that won't change, or their vertices are fixed like a cube, is what is called animated or skeletal meshes. What they do is that they represent your game characters, and they can move and they can deform, and you can do that by rigging the character. And you can again use a motion capture mechanism to import some sort of motion or realistic and natural movement to an object, or just use three-dimensional modeling tools such as Maya or 3ds Max to rig your model, usually create bones for your model, and then move your model parts around to recreate movements such as jumping, shooting, crawling, running, walking, and all that other kind of poses and postures, and through the rigging process. And then you can use this and import this whole package and information as a skeletal mesh within your game engine, and then you can use your Unreal to do that. And these will be also stored in the packages. We won't talk, if we have the time, toward the end of the semester about manipulating skeletal meshes. But that again depends on how much of the content of this uh, uh, course we can cover by the end of this semester. So what are the applications that you need to use? Of course, Unreal Editor or Unreal ED is the tool that you will be using. Right now, it is essentially called Unreal Development Kit. It's the world editor that is released by Epic Games, uh, which is essentially loading your game into your memory and the computer's memory, basically, and then you can use the game editor to manipulate, design a level, and manipulate your objects within the level and create the game you need. To create your assets, you have to use texturing programs to create two-dimensional images that you will apply on the surface of your images as materials and textures. To create objects, you use three-dimensional applications such as 3ds Max, Maya, or other kinds of three-dimensional tools. And if you need sounds in your game, you can use any kind of sound editor like Collada or other kinds of sound editors out there to create the contents of or the auditory contents of your game, and then use them as assets for your design. If you follow the installation of Unreal Development Kit or UDK, you'll see a screen like this after you load your game. It has 4 views. The bottom left view is your perspective viewport, and the other viewports are side, top, and front viewports that are essentially two-dimensional orthographic viewports that you can use to put your objects and align them together and work with your orthographic views of your level, and you can see the three-dimensional look of your game essentially within the perspective viewport. So go ahead and follow up if you haven't done so, the installation process and work on the first mini assignment, which is creating a simple level using your Unreal Development Kit. Later on, we will see that we can use three-dimensional assets that are created with 3ds Max. This is an example of an asset created in 3ds Max and a screenshot of 3ds Max to create a character here. And of course, two-dimensional picture manipulation tools such as Adobe Photoshop, the Coral Painter that you see here a picture of, ZBrush, which is a really new and cool tool to create and manipulate two-dimensional images, for the textures, and Collada plugin that you could use to create those images and apply them as textures. The sound programs that I was talking about, Unreal Sound Cue Editor is a really cool engine that manipulates Microsoft Windows sound files and the WAV files within Unreal Engine, or you can use dedicated sound editors such as the Sony SoundForge or Adobe Audition to create sound materials for your engines. So with that, I'll close up this first lecture, which essentially was an introduction to what the Unreal Engine is made up of. And then next week we'll start with creating a massive level without the details of each of the components that we work with. But then as we go on in the semester, I will break down each of those components and things that you did, like creating materials, creating textures, creating three-dimensional objects, particle effects, and things of that nature in more detail using visual scripting mechanism in Unreal called Kismet, and also the really cool cinematic effect editor called Matinee of Unreal. And we'll see how those tools and techniques can be used and manipulated to create a really efficient and very, very good looking game in Unreal. Okay, well, that would conclude this first lecture, and we will talk next week. Thank you.